Alright, so we are starting today with another lecture that is known as Numpy. What exactly the Numpy is? Numpy is the numerical Python which we use for the arrays, purpose of solving the arrays. Since we all know that Python is having many libraries in it, so and it is used for a huge data type that is in a huge data for having the huge number of or huge amount of data. We use Python language so that we can bifurcate that data into small chunks and at a moment of time, whatever the data is being required, we use it and we can accordingly work on that. Right? So for the same purpose, the Python programming language has entirely developed the arrays concept into its one of the most prominent libraries that is known as NumPy. So guys, NumPy stands for numerical Python. So we all know the flexibility of Python that it is having ample amount of libraries to which we always use a proverb for that Python is a kind of language whose battery never dies. So here are few points which are again extending the flexibility of Python. Like it is easy to extend language. It is having a very great syntax which encourages easy to write and maintain a code. It is incredibly having large standard library and third party. Right? If you are not having some feature available in Python, we can always integrate it. So if we talk about incredibly large standard library, so NumPy is one of them. So we do not have the concept of multi-dimension array, but with the help of syntaxes, we can extract elements out of NumPy. So NumPy provides the fast built-in object n-dimension array, which is multi-dimension array of homogeneous data type. Usually, we have seen that in whenever you are using arrays, we move only up to one-dimension array, two-dimension array, and up to maximum we move towards the three-dimension array. That way, when we talk about Python, we can have n dimensions of array, and we can work on those. Let's see how. So whenever we have to use NumPy for the systems, usually this library is there, but for the Anaconda distributor, it is there. If you are not having this library, then you have to install it with the help of Pip. And it's the website from which you can do and can move so on. So this is the overview of numerical Python, what it is having and how the features have been elaborated. So we are having n-dimension arrays of rectangular data. The elements of the array can be of C structure type language or simple data type. It is helpful in extracting and work on huge amount of data, which follows the fast algorithms and machine data types, etc. They are available, right? What are the universal functions it is having with it? Functions that operate element by element and return some kind of result. Fast loop registers are there, so it can easily perform on the specific tasks which are required to do. Now let's talk about the NumPy array. We have already seen the concept of lists and dictionaries and tuples and sets which are heterogeneous in nature. But when we talk about arrays, arrays are always homogeneous in nature. This means if you have defined it for one kind of data type, the list or the array list should consist of that, right? So NumPy array is an n-dimensional homogeneous collection of items that are of same kind, and you can use it. And we can use it. So this is how the n-dimension array is being defined. Let's moving ahead from here, from side. So right. So let's see how we are starting here. So NumPy array we have already discussed about that it is a homogeneous collection of items of the same data type. So to have NumPy in our system, we need to import it. Right? So we are importing it by the keyword import NumPy as n. Usually we take it sometimes as NP, doesn't make any difference. It's entirely of your choice. Say for example, if you are having some student named ABC in our class, so we can even simply put the name here, import numpy as ABC. That doesn't make any difference. So A is a variable in which I try to define the type of array, and M is the numpy. I'm using the pseudonym of this numpy or a short name of this numpy, followed by dot because we are trying to call the function named array here, and this array is of what type? It is of two dimension or three dimension, dimension. So I'm having few variables and values in it, 1, 2, 3, 4, 5, 6, and at the end I'm trying to define the type of this particular array. So what kind of type I'm defining here? It is of float type. Now by trying to print this particular array, I can get 1.2.3.4.6.5.6. So now what is the shape of this array? We need to discuss about it. I told you that it is a two dimension or three dimension. So let's see here. It is of this shape. It is of shape which is having two rows and three columns, right? So this is how it is being defined. Now print the shape with the help of print command a dot shape. We can see that what is the size of this array, and a dot item size means what is the size of this particular array. So size of this particular array is 8, right? So why 8? You can calculate it very easily. So now when you come to print that a dot d type, what kind of data type it is having, you can always see that it is of float type, right? Then if I'm having something like this, then we can again check directly that what kind of data type this particular array is having, and whether the type is okay or not. So we can always check it here, right? So moving ahead from here, we talk about the NumPy arrays, single dimension arrays. So let's see one by one how this is working. So simply, and very simply, how we are creating an array in NumPy. Always we need to start by, don't create any confusion here. You always have to write this particular keyword, that is import NumPy as NP, right? You always need to import that particular library. Now, for a simple array creation, A is equals to, the key here is the array, keyword is the array, and I'm defining a one dimension array, 0, 1, 2, 3, simple values. Now, while printing it, you can see that particular that data, that what kind of data, how many elements are there. If you wish to check the type of this particular array, simply type that particular name of the array. A. So you simply get the data type array, right? Now you wish to check what kind of data type it is having. So a dot data type, d type, if you are typing here, so get the answer integer 32, right? So it is a 32-bit data type of type integer. Now bytes per item, if you wish to see that what is the byte per item it is having, so a dot item size per element you will get this particular code number. Now let's see that what is the shape of this particular array is there. So shape returns a tuple listing the length of array along with each dimension. Right? So whenever you try to check the shape of any array, it will always return into a tuple type. Right? So a dot shape, you will definitely get 4 comma. Right? So there are 4 elements in that, and if the size or the dimension size increases after comma, you can have further elements. We have already discussed this thing in the previous classes, physical lectures of our class, that why this comma has been put over there. I do not need to explain it time and again. Now I wish to check the size of the array. Simple and simple, a dot size. It is just putting me the a of size. These are the two different ways in which we can write that how we can check the size of an array. We can always check that is of size 4. 1, 2, 3, 4. You should not be having any confusion over here. Right? Now if I wish to check, these are the basic fundamental functions which are inbuilt in the NumPy. So continuing in that, bytes of memory it has used here. So a dot n bytes. Returns bytes are how many? 2, 4, 2, 6, and 2, 8. So 8 and 2, 12, I guess. Some 12 is getting problem. What happened? 2, 4, 6, 8, and one more test taking, I guess. Right? So array of dimension is taking n bytes. You wish to check how many the number of dimension it is having. So a dot n dimension it is having one. You wish to copy, simple process is there to copy. Then you wish to convert an array into a list, so you are having a facility to list 0, 1, 2, 3, 4, right? Then for one dimension array, list also works equivalently, but it is little bit slow in nature. So 0, 1, 2, 3, I can always have that list with you and can work on that particular array source. Now, if you in the previous slides you have seen here that arrays has taken, we have put simple value, default values. What if you wish to put some values or different values in array? Can we do it? Yes, we can do it. How we wish to do. Now, a of zeroth is having zeroth element. There is zeroth element in it. Then, if I wish to push some another element at zeroth location, we are having this facility a of 0 is equals to 10. So my list will be pushed up like 10, 1, 2, 3 instead of 0 I'm having 10 here. Now what happens? These NumPy arrays are having huge uses in machine learning algorithms. So basically they are two, if we are having a picture, right? That picture when it gets finally converted into a kind of matrix in which the borders of image is being represented by the one and the rest of the part of the image is being filled up by zeros, right? So there is always requirement when we are converting that particular image into uh, uh, blurred image and then it is converted into a matrix. Then what we require to fill extra borders by zero, right? So there is a direct command for that, a direct function for that is a dot fill of zero, and it fills your entire matrix with zero, 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 right? Since it is a one dimension array, so four zeros if you are seeing here. If it would have been two dimension array, three dimension array, and dimension array, three cross three matrix, four cross four matrix, five cross five matrix. Then you can simply have that number of zeros for a 3 cross 3 element. How many matrix? Zeros will be there, 9 zeros will be there. Alright. Now, let us see if you wish to fill your the array of one dimension with one. So, you are having this particular way to do that, but it will be a little bit slow in nature. We are again having some kind of data, some kind of method available to simply fill the ones in that, right? Now, when we are trying to compare two data, then a little bit different ways there to do that. A dot data type, wish to check the data type, yes, it is available here. Then, if we wish to assign a float value in that, so I already told you that if array has been decided, then array always takes the homogeneous type. So what will happen if we add the zeroth location, you want to put 10.6 data in that, then simple thing will happen. It will truncate the decimal part out of it and simply fill the zeroth location with 10. So you will be getting 10, 1, 2, 3 like this, right? Now fill has the same behavior, a dot fill minus 4, comma 8. So let's see here what I really wish to do. I wish to fill 4.8 into my entire one dimension array. That is, instead of 0, 1, 2, 3, that is of previous array, I wish to simply put here, fill it with the minus 4.8. Now, what will happen here? Zero point 0.8 will be get truncated and my array will get filled up with 4, 4, 4, 4, 4, followed by this negative symbol everywhere. It won't be creating any problem. Right? Now, we have seen the one dimension array in its simplest way of using. Now, we are moving towards the multi-dimension array. What happens when we talk about multi-dimension array? So you can take n dimension of array. I'm here taking 1, 2, 3, 4, 2 by 4 matrix. Then what will happen? I'm already having some data here. I wish to display that data on screen. I can do that. So how many rows are there? There are two rows and four columns, right? So we can check about this particular thing for any confusion with the help of shape, right? You can write in both the ways, a dot shape or shape of it. How many elements are there to count it? We always have a size, a dot size or size of it. Then how many dimensions are there? So a of n dimensions we can check always. Get and set element. If you wish to put some element at some different particular location. Now it's a two-dimension array. So how we are going to work on it? We've got four-dimension array, right? So how you are going to put them? So now let's see at 1, 3 location, right? We want to, we are having some value named 30. At that particular location, I wish to add put insert, put not put, insert minus one. How can I do that? Let's check it out here. My row 1 and column 3. So row 0 and 1. Now moving towards column 3. 0, 1, 2, 3. So we are talking about